Welcome back, ladies and gentlemen. This is Dr. Robinson again. We are starting our study skills tutorial video with dedications for students who have written in questions about certain things they wanted to see me do. So we're dedicating the show to Jeannine B. Thank you so much for writing me, Jeannine, and I'm going to try to do my best to answer your questions on probability that you may have had. So there's Dial a Teacher Homework Helpline at 212-777-3380, Monday through Thursday, 4 p.m. to 7 p.m. So give them a call. They're nice people as well. You can watch my tutorial videos on YouTube. My channel name is Dan Robinson. Subscribe to our channel. Give us a thumbs up out there. Let us know how we're doing. Write a comment. I do write back. You can check out our latest release, PKMS Math Prep 19. We are working on PKMS Math Prep 20. Be out soon, so look for it. You can tweet us at drobmath1. Let us know what's going on. We have a math show, math time on Tuesdays at 4:30 p.m. to 5 p.m. on Optimum Cablevision, Channel 15 in Peekskill. Check it out. Good show. All right, Jeannine, here's your first question that you asked us. And which representation shows a proportional relationship between x and y? Well, there are three things that a proportional relationship has that you should be aware of. One, when you're dealing with graphs, so we have graphs, we have tables, so first thing you should know, you have to have a straight line. So let me get my straight line tool, and I'll choose that red line there. So it's got to be a straight line. So this is a straight line, and B is a straight line, but I notice uh, they're starting at different points. This starts at 5 and this starts at 25. Well, number two, the second thing you should know about a proportional relationship, it has a start at the origin. That's at the zero point. So the origin is right there. So the line should really look like this and not start at the 5. It should start at the 0. So that's what it should look like. So A is no good, and I'm looking at B as well. It should start at the 0. So I'm going to draw it so you can see it. That's what it should look like if it is a proportional relationship. Later on in 8th grade, you'll take a look at those types of questions and problems, graphs that start from different places on the y-axis. So A is not it, and B is not it, so those two are incorrect. So now our choices are narrowed down to C and D. So C or D. So we can look at a table and we got all these numbers. So how do we figure out? Well, we know there's a third thing that proportional relationships have to have. So one, it has to be a straight line. Two, it has to go through the origin. But the third and what I think most important, it has to have a constant of proportionality. The constant of proportionality is a fraction that you multiply the x by, fraction or whole number, you multiply the x by in order to give you the y value. So all of these x values, if you multiply by that certain constant number, it's going to give you these y values. So there's a magic number. Now, to keep you from guessing and trying to figure out what the magic number is, there is a formula, and if you check out my video on constants of proportionality, there's a video of formula for finding the constant of proportionality, and that's k is equal to y over x. That's the formula you should get to know. So we're going to use that formula, k equal y over x, and see what would be that magic number to give us the constant. So I'm going to take these y values, 8 over 2, and see if that is equal to 16 over 4. So I put the y value over the x value. Check out our video on how to find it, the constant of proportionality. And let's see if they're equal. And we got to check all of them. So let's write these others down. 24 over 8 and 32 over 8 over 12. So let's reduce these. If they're all equal to the same number, then we have our proportional relationship. And if they're not equal to it, then we don't have it. So they all have to be equal. So that's the magic thing. So 8 divided by 2 is 4. So far, so good. 16 divided by 4 also is 4. So far, so good. 24 divided by 8, that's 3. That's not equal to 4. So I have a problem right here. So there's a problem. I'll stop right here because they're not equal. Because in order for it to be a proportional relationship, all of these fractions have got to be reduced down to an equal number. So since this does not equal, I'm not going to even reduce the next one. I'm going to cross that out and take a look at the last one. So I'm going to start this off again with my formula. Y is equal to k over x. So 3 over 2, and I'm going to see if that's equal to 6 over 4, and 12 over 8, and 18 over 12. All right, 3 over 2, that's easy. 3 divided by 2 is 1.5. 6 divided by 4, that's also 1.5. Now it's time to get the calculator out. So let's see what the calculator says about these last two. So, and nice, I had them there, I see. So 12 divided by 8, that's 1.5. So far, so good. And 18 divided by 12, that's also 1.5. So I'm noticing, let's pull that out, all of these equal to 1.5 when I reduce them down to their lowest terms, all those fractions down to their lowest terms. So this has got to be the correct answer. So I'm going to choose choice D. That's my answer, because that one, I have a constant of proportionality all equal to 1.5. So choice D has got to be it, and yes, it is. K is equal to 1.5. So that makes D a proportional relationship. So let's go to our next question. Bendel has 6 teaspoons of salt. The ratio, and let me underline ratio because ratio means it's a fraction. And I'll even make a fraction bar over here of teaspoons. So a fraction of teaspoons, which is being compared to, so what are they comparing it to? Tablespoons. So we have a ratio of teaspoons to tablespoons. So we have a fraction of teaspoons to tablespoons. So let's write that out. Teaspoons as our numerator to tablespoons. So that's our fraction. The fraction says, or the ratio, and there's our ratio dots up there, is 3 over 1. The colon dots means the fraction bar. And now we want to know how many tablespoons of salt does Daniel have? Well, let's see what we got. We have 6 teaspoons of salt. So he has 6 teaspoons of salt already. So what I'm going to do is I'm going to set up a proportional relationship. Proportional relationships, proportions are equal fractions. So that's how I'm going to try to solve this. So I know I have 6 teaspoons of salt. I'm going to put that up here on the top because there's my teaspoons on top as my numerator. I'm looking for tablespoons on the bottom of my fraction. That's where I'm going to put the X because I don't know how many tablespoons that I have, so I'm looking for that. Now I have 3 over 1 is equal to 6 over what number? If you remember in the video, we cross multiply to solve for X. So we're going to cross multiply and solve for X. So we have 3 times X equals to 6 times 1. 3 times X is 3X. 6 times 1 is 6. Divide by 3. Divide by 3. 3's cancel out. X equals 2. And if you remember, we said X was our tablespoons. So that would be 2 tablespoons. is what then of salt is what Denville will have. So answer would be 2, and that's choice C. And if you can look at it, ratio, uh, if he had three teaspoons of salt, uh, that's just double the amount of now that he has 6. So that's double. So if I doubled the teaspoons, that'd be 2 times 3 is 6. So 2 times 1 would be the number of tablespoons. So that again, that would be another way of looking at it. So again, you would know your correct answer would have to be C, which is 2 tablespoons. All right. So I hope you understand what's going on. And if you're not sure, rewatch the video and write down your questions and send them in. All right. Here's another good question. What set of values make the inequality n greater than or equal to? Notice there's a line underneath that, so you have to remember or equal to. So there's two things going on. -5, true. Now we have a -5. Now, when we are using negative numbers, I kind of like to tell my students to use money when we're talking about negative numbers. So I'm going to put the famous $ there. And when we're talking about money, negative money, and we're talking about these inequality or comparison symbols that deal with less than or greater than or equal to, less than or equal to, I like to say use the word more than or better than in order to make it a little bit easier to deal with. So I'm going to say what numbers are better than or more than owing $5. So what numbers are more than or better than owing $5? Well, as I said, put a $ in front of that. And I said more than or better than or equal to owing $5. Well, is $5 is owing $5 more than $5? Owing $5? No, it's the same as owing $5. So that's the same. So this would be true. So it's true here. And let's look over here. Well, we have a -6 here. Well, let's take a look at that -6. Is owing $6 better than owing $5? Well, if I owe $5, that's less than, and that's better than owing $6. So I'm gonna get rid of C because owing $6, that's worse. So I want to get better than or better than. So owing $6 is going to put me in a bad situation. So I'm also going to get rid of D because owing $6 here also makes me think that this is not going to put me in a good state. So this is going to be wrong because owing $6 makes it worse off. I want to be better off. So being better off would be owing $5 because that's less money, but it's a better state. Now, I want this to be true now. So let's look at A or B. Now let's add a 0 to this. Owing $5.50, is that better than owing $5? No, that's worse. And there's that owing $6, that's also worse. So just because of those two, I'm going to take these out because this makes it worse. That's worse. You don't want to be worse, you want to be better. So let's look down here at B. So A is not looking too good either. So let's look at B. Owing $4.50, is that better than owing $5? Yeah, I owe 50 cents less, so that's good. I'll put a 0 there. Owing $3, is that better than owing $5? Yeah, oh, much better. That's $2 less. So yeah, that's much better. So again, I'm going to put dollar signs to represent these negatives, and hopefully it's a little bit more comprehensible when you use that dollar sign and negative when it comes down to owing money, and not using the term greater than or greater than or equal to in this case to try to figure out which is the better way of dealing with it. So think money to try to help you out. That's one way of looking at it, though. So I'm going to say the correct answer is choice B. That's the better proposition. And there we are. So that was a tough question. So think money, which is better off, which is greater than, because if you recall in integers, the farther you go to the right on the number line, the better off you are, or the greater the number. So the farther you go to the left, the smaller the numbers are. So that's another way of looking at it. All right. Here's our last question, Jeannine. Leanne collects data throughout the basketball season and uses the data to determine the probabilities of different teams playing in a league championship game. The probabilities for her four favorite teams playing in the championship game are shown below. Tigers, P stands for probability, by the way, is equal to 2/3. Redbirds, P equals 4/5. Bulldogs, P probability equals 3/8. Titans, probability is 1/2. Which of these teams is least likely? Let's underline that because that's important. They got that italicized there, so that's important. To play in the championship game. So here are the probabilities for her teams, her favorite teams. So the problem is they're all fractions. We need to change our fractions to decimals to make it easier to look at, or change these fractions to common denominators where you can look at them a lot. Look at the numerator and compare your numerators. So I'm just going to just change all of these to the decimals. Sorry. So I'm just going to take the first top number, numerator, and divide it by the denominator. Press enter. There's for the Tigers, and so they have a 0.6 repeating decimal, 4/5, 4 divided by 5, and that's of 0.8. And let's do one more. 3 divided by 8, 3.75. Let's bring those out because I don't think I have more room, but I will see. And 1/2, everybody should know the 1/2, but in case you don't, 1 divided by 2 is 0.5. So I can bring this whole thing out. Good. So there are your probabilities of all of them, all the teams. So we're looking for the least likely, least or lowest probability is the one. So it would be the lowest one. Well, the lowest one would be the smallest uh, number place value. So 0.37, which would be the lowest, 37.5% if you change it to a percent. So it would be the Bulldogs. So the Bulldogs would have the lowest one. So I'm going to say C would be my answer because they have the lowest percent. So I changed them all to decimals, and I chose C because it has the lowest one at all, even though I know 0.8 looks like it's small, but that's 80 cents or 80%, and I'm going to go with choice C. And zero point 0.5, that's a half of 50%. So you might want to change these to percentages if you want to see percent. I made a video on how to change decimals to percent. So, but the decimal is fine. We can check it that way. So the least likely one is the smallest percent or smallest decimal that would occur for them to win. And if you remember probability, we made a video on probability. The chance of something happening or not happening is between 0 and 1. So the closer you are to 0, the more less likely it's going to happen. So the one that's closest to 0 is 0.375. All right. So I hope you enjoyed the video, and check your understanding. If there's anything you're not sure of, rewind the tape and rewatch it and write down your questions and email them to me. Let me know, and I'll dedicate a video to you. Remember, there's Dial Teacher Homework Helpline at 212-777-3380, Monday to Thursday from 4 p.m. to 7 p.m. Don't forget, you can watch our YouTube study videos, and my channel name is Dan Robinson. Subscribe to our channel, give us a thumbs up if you like what we're doing, write us a comment, and let us know what we could do better to help you out. Our latest video on newest release was PKMS Math Prep 19. Check it out, very good video. Look for Math Prep 20. Tweet me at DRobMath1. Don't forget to watch our show Math Time on Tuesdays at 4:30 to 5 p.m. on Optimum Cablevision and Peekskill Channel 15. Remember, write me if you have questions, robinsonmath@aol.com, and I'll be glad to answer your questions and make a dedication to you. So I hope you enjoyed the video. Don't forget to look for Math Prep 2020 coming out 2020, and I hope you enjoyed the video. Remember, look for Dan Robinson. Please make sure you give us a thumbs up and subscribe. Look forward to seeing you at our next dedication video. Thank you so much. Don't forget to watch our shows. Take care. Bye-bye. Bye.